my name is Tommy, and today we're talking about heat capacity. If 0.02 mole KCl is dissolved in 100 milliliters of water and temperature changes by 1 degree Celsius, what is the total energy released? Assume specific heat of the solution to be 4.18 joules per gram degrees Celsius and density of water to be 1 gram per milliliter. Molar mass of KCl is 74.55 grams per mole. So the first thing to recognize is that what we want to set up is our energy equation for heat. So we know that Q equals our grams of substance, so grams solution, times our specific heat of the solution, which we know to be 4.18, and then our temperature change, or delta T, which we know is 1 degree. If it's not given to you as a temperature change, it's final minus initial, as every single delta is, or change. So, let's see. First, we need to convert from moles of KCl to mass, and then we can add that mass to the mass of the water, which we can get through the density of water. So let's do moles first. So 0.0200 mole times our molar mass of 74.55 grams per mole. Moles cancel and we're left with 1.49 grams KCl. So now that we have that, we'll calculate our mass of water. So 100 milliliters times our 1.00 grams per milliliter, and that equals 100 grams. So we can add these together and we can get a final mass of 101.49 grams of solution. So now that we have grams of solution, we can plug that in. Now there's one last thing that I left out. What we're measuring right now is actually the surroundings, and it's not the reaction itself. So what do? Well, whatever the reaction is releasing is going to be absorbed, or whatever the reaction absorbs is going to be drawn from the surroundings. So the energy from the surroundings is the reverse, or the opposite sign, of the energy from the reaction. So we can write that down as Q reaction equals negative Q surroundings. So what this really is Q surroundings. So what we're going to do is we're going to take the negative of it to get the heat of the reaction itself. And when you do all the calculations, you end up with 424 joules. Except it's going to be negative 424 joules.